Hi, I'm Tom Smith here from Do It Yourself Home Automation, and I'm talking with Eric Wengrowski. He is the co-founder or founder of, are you founder or co-founder? Actually, I'm not sure.
I have a co-founder.
Co-founder, okay, great.
Yeah.
Co-founder of Steg AI. They're a really exciting company doing work in provenance and image tracking, and some really cool other kind of AI tech that might ultimately tie into NFTs. So I'm here talking with Eric, and we're going to talk about his company. We're going to talk about the interesting applications to the stock image licensing industry, and some things beyond that. So welcome, Eric. Thank you for talking with me today.
Tom, thank you very much. Happy to be here.
Awesome. So just want to just to get started, want to ask you if you could just tell me a little bit about your background. We've known each other for a bit now, so I know. But can you let my viewers know about who you are, how you got involved in computer science, and your kind of path into machine learning and AI?
Yeah, sure. So Steg AI was formed in the autumn of 2019. And before that, it was sort of an outgrowth of some work I did in grad school. So I went to Rutgers University. I'm actually from New Jersey originally. I went to Rutgers University where my father and my sisters went to. And I studied electrical and computer engineering there. Mostly because I wasn't very good at chemistry. I was interested in computers. My parents had a gateway desktop with Windows 3.1 for email and solitaire and stuff when I was a kid. I had no idea how to program or anything like that when I got to college, but it sounded cool. I got to college. I learned that there was a lot to learn. I majored, I mentioned my major already. And then at the end of undergrad, I became introduced to this field of study known as computer vision, which is essentially AI for image, video, any kind of like visual based medium. So I like to describe it sometimes as reverse engineering the human visual cortex. But the applications have really expanded. So self-driving cars, facial recognition, things like that, it's all computer vision. I really fell in love with this subject, and I decided to stay at Rutgers and pursue a PhD with Professor Kristen Dana, who became my co-founder later on in life, and study computer vision. Now, stop me if I'm going on too long, but while I was working on computer vision in graduate school, the deep learning revolution happened, and it heavily influenced the research that I was doing and the types of papers that Kristen and I were publishing. And early on, we were working on this problem that I thought was cool with some communication folks of how do we embed information into pixels. And we wrote several papers on this subject and had them published in some really great places. And over the course of years and years, our thinking really evolved and led to the technology that Steg AI now uses as its core.
That's awesome. Yeah. So that I think answers a little bit about who you are and also how this came to be. And it sounds like it came directly out of your academic research and as really high level collaboration. So that's really cool to see. So, I mean, I know a little bit about what Steg AI does. I know it's something that's still in development. I know some parts of it are proprietary, but I tried to look at some of your papers, and a lot of it was there was a term that I think led to the name of the company that I had trouble understanding or even frankly pronouncing. So can you, as an expert in this area, tell us a little bit about Steg AI and the tech behind it, and maybe try to explain it was like Stegan something. I'm not even going to attempt. What is that technology?
Yeah, sure. So I think you're referring to steganography.
Yes, that's right.
Yeah, so steganography is this really old practice of how does one conceal information inside of another medium. So if I could write a letter to you in invisible ink, and then you knew how to read this letter, that would be an example of steganography. The computer vision and other computer science communities have been working on this project and on this problem for a really long time. It became very popular in the 90s and early 2000s, where the idea was, rather than using disappearing ink, how can we conceal information in a file or maybe in pixels for an image, such that this information is invisible to the human eye, but readable to a computer, or in our case, even a camera. So this, we were fortunate enough over the course of my research work with Kristen to solve some key problems relating to human vision, relating to synchronization, and we were able to leverage deep learning to kind of take this tech to a new place.
Yeah, that's awesome. And I mean, is this is something, so basically my understanding of it, tell me if this is right. I would take an image, say I'm a photographer, I am a photographer. I take a picture and I want to embed something in it. I want to embed a code in it, maybe to track it. I can put that in the IPTC metadata, but somebody could take that out later. They could forge the metadata. With your technology, I'm kind of altering the pixels in the image to embed that code. Is that right?
Yeah, that's right. So you're absolutely right. Metadata, as it normally stands, is fairly easy to strip, and it's routinely done so. So for a period while I was in grad school, I was working at Microsoft Research, and I was working on a problem about storytelling. Basically, how do we automate the process of storytelling with photos and videos and deliver a video or something like that that's fun to experience. And we were heavily reliant on the metadata that was associated with the photos and videos that we were using. But we realized quickly that this was a big problem, because when you upload your photos to Facebook, Facebook strips out the metadata very quickly. This is just routinely done. So it really got us thinking about, okay, how can we do something that's more immutable, something that is stronger? And you mentioned before IPTC metadata. It's a wonderful standard. Where we're thinking now is, rather than having the IPTC metadata be something that's attached to an image, but ultimately strippable and separate from the image, what if we took IPTC metadata and embedded it directly into the pixels of the image? So the image was fundamentally linked with this information, and it could not be stripped out.
So does that change the way the image looks? Because to me, as a photographer, I'm spending all of this time, in Lightroom, editing and getting the colors just right, and not always, but sometimes trying to get everything perfect. So does it change the way the image looks to embed this data in it?
Yeah, so that's a great question. That's the tricky part, right? I could put it this way. When you have a photograph, let's say, and I want to embed some information in that photograph, you're going to have this trade-off between visual quality, as you're describing it, the capacity of the payload. So basically, how much information can I fit in there? And then also the robustness of your watermark or your steganography, whatever it is you're doing, so that it's harder to strip. It can survive being printed out on a piece of paper and captured by a camera. So these are absolutely the technical considerations. And this is kind of our secret sauce, right? Is how do we do these three things well, that it actually works, and that when you're looking at your image, this isn't a problem. And the way we've done this, and I've mentioned kind of deep learning in a hand wavy way before, the way we do this is by relying on deep learning to simultaneously solve all of these issues for us. So what this means is, when I go to an algorithm of ours that we've trained to combine data with an image, the first thing the algorithm does is it scans through the entire image, and it uses a very sophisticated human perception model to figure out, where can I make changes to this image such that a person will not be able to detect these changes, but I, a computer or a camera, will be sensitive to these changes.
So it's basically altering the pixels in a way that tries to preserve the image for people as much as possible.
Yes, yes. The goal is invisibility for people and visibility for a machine.
And so how much data can you actually put into the pixels of a typical image?
That's a good question. Um,
And
so
keeping
what
in mind, this might be proprietary, feel free to tell me. I can't speak to that, or, if I tell you, I'd have to get an NDA or something like that. But yeah, whatever you're able to share.
It's a good question. So what I can share with you is the information that we published in CVPR 2019. So CVPR is a big computer vision conference and publication venue. And at the time, we were embedding 1024 bits into images that were 256 by 256 pixels. So relatively small square images that had a relatively high payload capacity.
Okay, so if I had a bigger image, even one that would be the resolution you'd have at the top of a news story, which to me as a photographer is probably 1024 pixels, you can get a decent amount of data in there in a way that's not going to alter it too dramatically. So that's definitely interesting to hear.
I should point out that the number I just quoted is from 2 years ago. It's from 2019. And fortunately, or unfortunately, computer science tends to evolve very quickly. So what we're doing now is a little bit updated, but I can't really speak to it.
So I've heard and I've seen there's other standards that have been around to do something similar to this, embedding data into pixels. How is yours different? And is that right? Are there other ones out there?
Yeah. I mean, there's been watermarking technology, as I mentioned before, and steganography that's existed for, even in the computer science world for 20, 25 years. Digimarc is a really well-known company that has been doing sophisticated types of watermarking in the print medium mostly for a long time now. I don't want to go into the details of how Digimarc's algorithms work because I don't want to get in trouble. And I really don't want to say the wrong thing and have somebody correct me. But I could tell you what we did and how it was new. So it relates to your earlier question of capacity. So the first capability we have is that we're able to generally embed much more information into pixels in a reasonable way than could be done previously. So, I mean, you could think about it. I could potentially embed a video or a song in the right kind of image, not just some text. One of our biggest innovations is that our watermarks are robust to something we call camera display transforms. So basically what that means is that I could take an image and I could put it on my computer screen, or in a slightly different case, I could print it out. And while it looks great to me, I could take a picture of it with my cell phone camera. And my cell phone camera can actually read the image and decode all of the information that's stored in it. And we were able to accomplish this by explicitly modeling these camera display transfer functions with deep learning. It's kind of hand wavy, but this was one of the main innovations we were able to publish.
Yeah, so that was kind of what was one of the things that was amazing to me about your technology. And just to recap for people, I'm a photographer. I take a picture. I use your tech. It uses machine learning. It finds the spots in the image that you can alter without kind of degrading the image for a person. So that's neat. Content aware. It's altering the pixels in a way that embeds a fair amount of data into that. And it sounds like what you have is, not just the amount of data, it's the robustness of the data, right? So I always have the fear as a photographer, I publish my photo, it's locked down in some kind of a frame that prevents it from being right-clicked and downloaded, maybe even prevents it from being screenshotted. SmartFrame comes to mind as a player in our industry, that does that kind of work. But there's always the chance somebody comes along and takes a picture of it with their phone or something. So how do I prevent that from happening? It sounds like your code is so robust that once it's embedded in my image, even if someone comes and takes a shot of that, or they hit print and then they scan it, it's actually going to stay in those pixels.
That's right. This is actually, so you mentioned this from a photographer's perspective, which is really interesting. Years ago, I was working during grad school at a company called Kitware. And I was working on a DARPA-funded project called Metaphor that is specifically an image forensics project. And the goal of image forensics as like a research field is basically to figure out where does this image come from? Is it trustable? Is it real? Things like this. So there've been all these really great techniques developed to answer these questions in different interesting ways. The classic techniques are actually looking for signatures of JPEG compression in the image and seeing if there's any major spatial inconsistencies, because you can usually detect if somebody copied and pasted a part of an image into it or removed something. There's a professor called Hani Farid, who's done a lot of really amazing work in this field. But one of my favorites is he wrote a paper with some collaborators analyzing the photos of Lee Harvey Oswald, where he's holding the newspaper and the gun prior to the JFK assassination. And he was broadly looking at two techniques to see whether or not the content of this photo was trustable. First was Oswald's pose, which people had for a long time said didn't look right, didn't look like a stable pose. And the other was shadow consistency in the image, given that it was taken outside and shadow should be behaving basically the same way given the single point of illumination. And he found that, to his analysis, these photos were trustworthy. When I was working on this project, I was constantly looking at, not at Hani Farid's project, but on the Metaphor project, I was constantly looking at photos that were coming out of foreign nations that were doctored and trying to think about how one might detect automatically these changes. It's kind of a long-winded way of saying that the big problem we always had is for almost all of these techniques, they were really easily defeated by just printing out the image and taking a picture of it. These algorithms that were amazing, and a lot of them are still state of the art, just wouldn't always work under those conditions. So for me, I felt like, okay, this is a real opportunity to add something of value where there is currently a deficit.
And so what Steg is doing, it sounds like, is creating something that's more robust, where you can print it out, you can take a screenshot, you can do all these things, you preserve the code, and you're able to still link that data up to the image. Yeah,
that's right. I mean, I would say that many image forensic techniques are not robust to what we call re-imaging attacks. And yeah, what we're doing certainly works with cell phone cameras and TVs and printers and stuff like that.
Yeah, so that's exciting to me as somebody who would potentially want to protect my photos, but I think there's a lot of other really exciting applications for what you're doing. So I mean, you embed this code in the image, you're able to reference it and pull it out even if somebody takes a photo with a cell phone or prints something out. What do you do then with that code? So what are some of the things that somebody could potentially do by embedding this kind of code in an image?
Yeah, that's a question I was really interested in after we had created the technology. So I think academic research works in a in a funny way, where oftentimes you're motivated by problems and you're motivated by interesting ideas, but there's a large gap between what, say, like the market is currently looking for and what academics are working on. There might be a 20-year gap or something like that between technology to product. So to answer this question, some of my founding members of my team and I enrolled in a program that the National Science Foundation runs called iCore. And it's designed for academics who have had research that was funded by the National Science Foundation to explore the commercial viability of what they've created by conducting customer discovery interviews. So Kristen and Roan were two of my co-founders and advisors at Steg AI. Were instrumental in this process, and we spoke to folks in advertising agencies. We spoke to folks at movie studios, TV, social media, because we knew that we had a technology that was very broadly usable, but we didn't know, okay, where is there an existing need right now that we can fill? And where we ultimately landed was this place of provenance and copyright protection, where there is a big problem. But looking forward, I think that there's a big opportunity for us to work in some of these other markets that I've discussed, including NFTs. So, I have a little bit of experience with some blockchain stuff I did in grad school, going back to like 2014. But I certainly don't consider myself an NFT expert, just somebody who's highly interested in NFTs. But my understanding of NFT technology is that you have a file, which is the actual NFT, and that file exists on the blockchain. We all know, I'm going to assume your audience knows what the blockchain is. It's a distributed ledger, and there's lots of variants. We're going to skip all that. But what a lot of times NFTs are used to link to like an image or something like that. So I know this spring we were hearing all this news about digital artwork that was being sold for enormous amounts of money as NFTs. But I think when you really break down what is happening here, the NFT file just contains a pointer to this image. So the image itself is not stored on the blockchain, just this kind of receipt is stored on the blockchain. And this image might be stored elsewhere. It might be on somebody's web server or whatever. So if the location of that image ever changes, your NFT probably is not going to reflect that change. So this leads to something called the disappearing blockchain problem, where, hey, I bought an NFT. I've been told it's immutable, it exists forever. And where's my image? Where did it go? Well, maybe where the image was being stored got deleted. Maybe the website went down, something like that. So where I'm really interested in exploring is creating a two-way link that just currently doesn't exist between the image itself and the NFT, and then the NFT to the image.
So to kind of, if I understand correctly, the way that would work, I create an NFT, maybe I take one of my photos, I turn it into an NFT, it's registered on a blockchain, I get a token representing that. The photo itself is still going to be somewhere else. Maybe it's on my server, maybe it's hosted by a platform, but say that platform goes away in 10 years or my server goes down. All that a buyer of that NFT would be left with is that token itself, that record on the blockchain, not necessarily the actual image. But with your tech, you could take the actual image, take the token or the pointer, and actually use your technology to embed that pointer into the pixels of that image, so it travels with the image itself. And if somebody found that image anywhere online and read it with your tech, they could find that pointer and reference back to the blockchain and see, hey, that belongs to Thomas Smith, or was created by Thomas Smith in any event.
Well said.
Yeah. So is that right? Is that
yeah, that's a very good explanation. It's much more succinct than I was able to do. That's very good.
Well, that's great to know. Yeah. I mean, that's exciting to me for a couple of reasons. One, obviously unifying the actual image with the NFT is exciting. It also, I imagine, is really good for provenance and making sure that NFTs don't end up being kind of duplicated. So one of the challenges, as I understand it, is that, say I'm a photographer. Again, I keep coming back to myself because this is the space that I know, but I mean, maybe I'm an illustrator and I create this beautiful piece of NFT art. I register it on a blockchain. I sell it for, $10 million, fingers crossed. And then I say, wow, that worked really great. I could go and take that same image and sell it on some other blockchain, right?
You could mint a new NFT for the same image. That's
Yeah,
right.
I could just keep doing that endlessly. But if I took that image and as soon as I created it, I used your tech and put the NFT token right in, say someone else came along and tried to mint their own NFT from it, your code would be in there, right?
That's right. Yeah, I know you've heard me use this example before, but I like to describe an NFT kind of like a deed to a house. Mm-hmm. So the house exists separate from the deed. The deed is your proof of ownership, but you can't live in the deed. And the reason why the deed works is because I've got a copy and the town keeps a copy. And as long as those two copies align, then that's great. I can't scribble things out I can't change the address to point it to my neighbor's giant great house and then say, yeah, I own it now. The town's going to say, wait a second, buddy, it does not work like that. But because NFTs are decentralized by nature, there is nobody checking to see this double mint problem. So, with a house, not only can I not change the NFT, change the deed, because it won't match up with what's on the blockchain. That sort of exists now with NFTs. I can modify my own copy of the blockchain and the NFT, but it won't agree with everybody else's, and I'll be left out in the dust essentially. But I can't sell my house to you and then go to somebody else, print out a new deed and sell my house to them. But you can currently do that with NFTs. And that is one of the problems that we're trying to work on. Now, the way for this to really work is for this provenance history to be immutably attached to, let's just keep using the case of an image, when the image is born. And, I can't really talk about this, but I could tell you from a research technology perspective, stuff that I've worked on, it is certainly possible inside of a camera to embed information, embed an invisible watermark that contains provenance information actually at the image sensor. So when I was working with some great folks at NYU, Pavel Koras and Nasser Memon, this was our area of research. So it's certainly possible, and I think it's going to be an important tool for provenance in lots of different important use cases going forward, especially as this trend continues where seeing is no longer believing,
So if I'm taking a photo, my camera would have some special software, and I take that photo. The instant I take it, the camera is registered to me. There's a embedding of a code into the image itself that identifies it as being taken on Tom Smith's camera, and it's in the pixels, and it's registered on a blockchain, ideally, or some other immutable technology. And then from there on out, no matter where that goes, or where it lives, or who might come along and steal it or buy it or whatever, it's always able to be tracked back to me.
Yeah. So there is, just to go on a research tangent for a second, there is an existing technology called sensor fingerprinting that doesn't quite do this, but is similar. It's actually some of the only image forensics technology that is admissible in court as evidence. And basically, digital image sensors that are inside our cell phones and our cameras have unique properties to each individual chip. So I can take a picture, and assuming that I have a very large collection of pictures from my device, I can actually test whether or not that photo came from my camera. So it's been used before to do a provenance history. What we're talking about is an evolution where we can embed more purposeful information. We won't have the same requirements as to, I need this giant database of photos to exist for me to check against. And something that, of course, as you mentioned before, can be placed on a blockchain, placed on a trusted distributed ledger, excuse me.
Yeah, so you could do this for somebody's photos potentially after the fact. I've got an archive of probably about 500,000 photos from the last couple of years from one camera. So you could go back and analyze the specific signature of the sensor in my one camera, and then, apply that technology to verify all my images, embed a code. Sounds like there's a trade-off. Again, I know a lot of your tech is proprietary. It sounds like there's a trade-off between the robustness of the code and the amount of data that's being stored in an image broadly.
Yeah.
So does that mean if I just am embedding a small token that points to blockchain, I can embed the code in that token more robustly? It's harder to pull it out of the image, and that way the data sort of lives elsewhere, and it's a pointer.
That's exactly correct.
Awesome. So yeah, that's exciting again too, because then you don't have to be putting, this was created by Thomas Smith on this date, on it, that data could live in this externally verifiable blockchain that's immutable and can't be altered. And the pointer could be embedded into the image and associated with my camera. The challenge I see right now, maybe you can speak to this, is minting a new NFT is kind of pricey. So if I took a photo and every time I did that, I had to mint an NFT to make this link, I think I'd be spending a lot on my 500,000 photos.
Yeah, unfortunately, this is where my knowledge kind of comes to an end. I know that there are many different blockchain options, some of which are much cheaper than others. I think there's trade-offs that you as a minter might have to make, especially if you're in a collectible space, as to how which blockchain you choose might signal to buyers differently the value of the NFT that you're selling them. But then again, there's convenience choices you might want to make. There are some, I don't even know what the price to mint on Ethereum, $50 per image these days. But I know that there are much lower cost options as well.
So maybe for my day-to-day minting, I would use a basic blockchain, and then if I wanted to register a photo I expect is going to sell pretty broadly, I could use one that's more well-known and more expensive. So that's exciting. I think just the idea of a new use for the blockchain and a new way to handle this issue of double minting with NFTs. But I imagine there's a lot of other potential uses. And the one that came to me when we originally talked about your tech is, tracking the way that images are used online. Is that something you've looked into at all?
Yeah, certainly. I could draw you an analogy. So in the motion picture industry, when a movie is pre-released for Oscar copies or for VIPs that want to get an early look, the movie is typically clumsily watermarked with the person's name across the bottom. And even though there are issues with this, what it allows the owners to do is say, well, if we see a copy on the Pirate Bay, I know who this came from.
Yeah.
Obviously, for photographers, nobody wants to put a big ugly stamp on their image or a QR code on their image that is going to distract from the visual aesthetic that they've created. But with a technology like ours, you could do something without this trade-off. So in essence, if I wanted to upload, let's say I'm a photojournalist and I want to upload some photos I've taken to Reuters and to Getty and to Shutterstock. That's great. And I want to use all these platforms to really maximize my potential revenue for the valuable work I've created. The problem is if my IP is being misused somewhere, at the current state, it's basically impossible to tell where it came from and who should be doing that enforcement. If you're able to say, this was the version that was on stock platform A, this is the version that was on stock platform B and C and so on, and then you see your image out in the wild where it's not supposed to be used, you could then look at the embedded code that you've placed in your image and say, okay, I see this came from stock platform C. So it really gives you much finer, I'd say a refinement of this enforcement and just knowing how your images are being used out in the world and where.
So you could potentially even do this for an individual customer, right? If somebody, say someone comes to stock platform A and goes to download a comp of one of my photos, the platform could embed your code, Steg's code, into that image, identifying not just the platform, but the customer, just like that, the Oscar copy, but digital. And then if somebody leaked that or used it inappropriately, I could go and say, okay, not only is this from this platform, but it was downloaded by this specific customer, and that would give me some enforcement options. Is that right?
That's absolutely right. I could embed an extremely fine level of detail, who I am when this photo was taken, when it was uploaded, more than just who the stock platform is and more than just who the customer is.
So where they were when they got it, and a lot more data. So that would be, I'm sure, very helpful on the enforcement side. There would have to be either, I would imagine, at the moment, I'd have to notice that potential infringement had happened. But I imagine you could also have some kind of a crawler that went around the internet and looked for, any kind of photo use and scanned photos for your code. How hard is it to scan a photo and see if Steg's code is embedded in it?
Well, that process is very simple, and that is something that Steg AI currently offers through our API and our web app, is not just the ability to encode, but also the ability to authenticate. So that's not a problem. Of course, there are limits to what you can do. Crawlers have limits, but we've designed our solution specifically so it can integrate with existing crawlers, existing enforcement solutions.
Awesome.
Yeah.
Yeah. Well, it's such an exciting technology. Where are you going next? Like, what's the next step, not only for Steg, but also for you personally on this tech?
Yeah, I mean, this, I'm very fortunate to work with a team of people who, many of them I've known for years and years and years, and have been very supportive to a frankly ridiculous extent. And helping with this venture, I think for me, it's a very interesting thing to be able to develop a technology and see it through the research life cycle, and then just kind of keep pulling the thread to see where it leads in commercialization too. I'm really excited about having Steg AI technology just become more ubiquitous, because there's so much that we can do with this idea of just embedding information, especially camera readable information in visual media. Beyond copyright enforcement, I love the idea of, even though we're not doing this now, just being able to sit on my couch, and if I see something interesting on my TV, just point my camera at it and say, oh, that's who that actor is, right? Or or something potentially much more clever than that. Um, so yeah, for me, the goal is to have our product and our technology being used in as many places as possible, and just helping as many people as we can with it.
So it's sort of like almost anything could become almost like a QR code that you could scan. It's like an augmented reality. I could even take my house and paint the outside with a code and be able to put the deed reference in there to torture that metaphor a bit, take it a little too far. But I love the idea that you're watching a show and you scan it with your phone, and there's a Steg code embedded in there. And you can pull out a reference and see, the actors, or see even what the photographer was, to be able to do robust crediting to photographers in images. I think that's really exciting.
Yeah, it's funny you mentioned QR codes. When we were first exploring this, QR codes were a great analogy from a technical sense, but they were kind of a poison pill, because people would say, "Oh, QR codes it's kind of old hat. They're kind of ugly. People don't really scan QR codes." And weirdly, I've noticed just during the pandemic, I think QR codes have had a real resurgence, especially with restaurants and menus. I'm planning a wedding this summer. We actually have a QR code on our invitation.
Yeah.
So it works a little bit better now.
Yeah, well, that's really exciting. So if people want to work with you in any capacity, whether that's partnering with Steg to use the technologies, if I'm a platform and I want to integrate this technology, how would I approach you? How would I do that?
Yeah, I mean, we're early stage. I'm always happy to talk to anybody who can lend their expertise to me and tell me about their journey. And just, I love learning more about other business needs that people have, and kind of creatively brainstorming on if there's something we can do, if I can point them in another more helpful direction. So I love it when people reach out to me. I'm available via email. My email address is eric@steg.ai. And yeah, in the near future, we're working on some pilot opportunities that I'm very excited with, and we're really looking for more of those. So I think I'd be happy to talk to anybody who wants, some of the best ideas have been I get in a room with somebody and we're chatting for 40 minutes, and hey, we haven't thought of that use case before, but that's a big problem for us, So I'm very, very open to hearing from new people.
Awesome. Well, thank you again for joining us. For people who are following along here, follow my channel to hear more about. I'll stay on this with Eric in the future. And again, reach out if you have an interest in this technology, you want to learn more. I've worked with you, Eric, and we've been talking about this for, I think, over a year now. So definitely reach out and follow here at Do It Yourself Home Automation. If you're seeing us on another platform, follow along, and I'll continue to explore these kind of new technologies with Eric and other really exciting thinkers like him. So thank you, Eric, so much for joining us here and for talking to me today.
Tom, thank you so much for having me. Really appreciate it.